So as you are the chairman, you should say something, but I think you already did the introduction, right, Hans? He did. So we are free to go then. Son.
Yeah. Ladies and gentlemen, first of all, I would like to thank the organizers and Professor Leuenberger for this great opportunity to present our research. Also, I would like to thank our sponsor, the company Rasa, for making all of this happen. So, you might be wondering a bit, just a bit of course, about our funny appearance. Well, my dad over here and I are firefighters from a small island with the funny name of Omans. And we are also trained lifeguards with a first aid education. This is one of our turnout gear for such tricks.
So in case something happens, we are prepared.
Exactly. Exactly. So, yeah. And we thought we put it on in order to show you, to show you that we have a little bit of practical knowledge about the human brain. You see, being a firefighter or a lifeguard isn't all just driving around with ta-ta, but it is a lot of hard work and also experiences which can leave dark marks in our consciousness. I don't think I need to tell you the problem with the post-traumatic stress syndrome. So knowing a lot more about the human brain can help us in our daily life and voluntary tasks. But this, however, was not the reason why the talk or why this project was started in the first place. No. After all, the name of this talk is about love and not post-traumatic stress syndrome. It starts with the name love. So when I was 14 years old, I actually got interested in this funny species of women. And in order
It was girls then.
Yes, girls. Well, you know. And in order to not mess anything up and do it properly, I asked my father about the attractiveness potential of certain feelings. And while doing that, I tried to leave out the female attractors since I was only 14 years old. But he figured it out anyways. So, but yes, naturally, where there's love, there can also be the opposite, which is to say, hate. And the whole work becomes a lot more complicated because of that. And yeah, it just stands in our way of trying with our desire to understand the world a bit better. Now, in order to stay neutral, or rather to say as neutral as possible, to extract ourselves from the equation, as my father always likes to say, we came up with the following quite simple strategy. And here I will now recite from the abstract if that's okay. I'm sorry if that's a bit boring, but I have to. There are more and more approaches to try and understand the world of feelings such as love, hate, fear, anger, and so on, plus consciousness in general, sub and unconsciousness via quantum concepts. A standard drawback to such attempts seems to result from the old problem that our current quantum theory is not of metric origin, or in other words, does not appear to be fully compatible with Einstein's general theory of relativity. This lack of a true quantum gravity theory does seem to be the major obstacle for all our attempts to understand consciousness. After all, it well could be that our feelings and consciousness in general, potentially embedding both quantum and cosmic scales, require a truly scale invariant and thus metric theory. In order to overcome these difficulties, we explicitly try to avoid to push any existing theory into the comprehension of the human mind and all its derivations, but instead started our consideration with the assumption that everything, including consciousness, may consist of attributes or properties. Subjecting these properties to a general Hamilton extremal principle, thereby using the Riemann theory and Hilbert techniques, we most surprisingly ended up in a generalized Einstein field equations. That's what my father is going to show you. These equations do not only contain the full theory of general relativity, but lo and behold, also include all main quantum equations, be it for Bosonic or Fermionic entities. The whole ensemble undoubtedly has the characteristics of a quantum gravity theory, and the best part of it is, it was already here for about 109 years. In this talk, we are going to apply our approach into the interesting field of love and the topic of feelings in general. Thereby, we will not only consider the aspects of feelings for an individual, but also investigate phenomena coming into play where ensembles of human beings entangle. This reaches from observation of so-called mass formation to the simple question whether an economic entity, a company, can be good. So now I give my word to my dad, and let's get right into it.
You almost want to say mass information. This is a Freudian, you know.
Yes, I'm sorry.
Okay, I know. Yeah, thanks. Well done, son. So, I know this is a rather bold claim we have here. We say that we do not only have thought or think we have a way to understand the human mind, that we even do this by the means of a quantum gravity theory. One theory, one says it's not there yet. So, of course, I have to give you proof that we have it. But the most amazing thing is we were not the one who found it. We just digged it up again. It was already there in the paper of David Hilbert from 1915. The stupid thing is, however, well, it's not stupid, it's amazing that scientists never look back. And if they do, they obviously do not do it properly. He had no chance to see that he had both the general theory of relativity and quantum theory, because quantum theory, at least in its main mathematical formulation, came later. Schrödinger was 26. Dirac was 28.9. In between was Klein-Gordon. So, and all those Bell equations came much later, 50s, 60s, and later. And they never looked properly whether one could also directly obtain the quantum equations from the Hilbert technique. They also used variational techniques, but never in the rigorous way of the Riemann, Hamilton, Ricci, Bianchi approach. Maybe they didn't like tensors. And I show you how we can achieve it there. But I have to point out again, we didn't do it. It was already there. So, okay, we just, when starting with something like trying to understand the human mind, one better tries to extract oneself from the equation, puts nothing in there which could mirror just one's own desires, but says, okay, let's assume everything is properties. You can name the attribute, the properties attributes or degrees of freedom. It doesn't matter. In the end, it's just dimensions. And when we have dimensions, they always span out of space or a space-time. And what we can do with spaces, the moment we have formulated them, no matter of what they consist, Hilbert has shown us what to do with it. We throw it into a variational principle. Here, this is slightly generalized, the Einstein-Hilbert action, minimum principle. It is being written as an extremal principle, but there is no need to really have it as an extremal principle. Just the variational principle is of importance here. Things can vary. There is one thing which is absolutely certain in this universe. This is uncertainty. You can take it into account by even darting the equal sign between the zero and the variation. But this just leads then to eigenequations and does not overcomplicate the whole thing. The only thing Hilbert has never used is that he has distinguished between the volume part of a matrix. The matrix is the object he investigates, which shows him the property of space or the ensemble of properties of space, forming the dimensions, forming our space. And then you just distinguish between the core of the matrix, or the pointer, you fix the class of the matrix, and then you put a factor on top. This is the simplest way to just generalize Hilbert's approach. And then you go through the Hilbert process again, and what do you get? The red ellipse is Einstein. Einstein's vacuum equations. So you get the same result plus something else. And now you might remember from school that when you have the vacuum equations, everything else in there is matter and energy. So all the rest just coming out from this little factor here at the beginning, the F, obviously is something plus the vacuum space. And then you investigate the properties of this else. And what do you get? Well, the most fundamental quantum equation there is, this is the Klein-Gordon equation in arbitrary numbers of dimensions. And it is well known, I just attended the lecture of Professor Rowlands, how to derive from the Klein-Gordon equation the Schrödinger, the Proctor, and the Dirac equation. It's all in there. But the thing is, it's not in there in the Klein-Gordon equation. It has been in Hilbert. In the whole Hilbert approach, it's in there. So now let's apply this. So there should be a matrix for the hydrogen atom. There it is. It's a matrix with potential and everything. Nothing is postulated. It comes out from the Hilbert concept by just distinguishing between the volume part of space and the components of space-time. The harmonic oscillator. And even something which has the energy signature of a half-spin particle, so fermionic character. So we had already shown that with this old concept, the Einstein equations can be obtained plus the quantum equations and known quantum objects like the harmonic oscillator, the Schrödinger hydrogen atom, and spin half particles, which is to say fermions. So how about something unsolved? Well, we attack the three-generation problem of elementary particles. What do we need in order to obtain a solution for the problem of the three generations? It would be electron, muon, and tauon in the case of the charged leptons. Well, of course, if you want to have three solutions, you need a differential equation or polynomial of third order. Let's see what this generalized Hamilton gives us. We just take our equation for the simplest case with a functional scalar factor, call it Q, and subject it to something being called the contracted Bianchi identity. It comes out from the symmetry properties of the Riemann tensor. It's pure math. There is no physical rule, no postulation, nothing. So far, it's pure math. It's a variational principle, and now it's the Bianchi identity applied to this variation principle. And of course, when applying the whole metric tensor, this is a covariant derivative with respect to a certain tensor, then the whole thing should give zero. But wait a moment. Wait a moment. We can also apply this tensor and leave the factor out. Then the thing does not give zero, it gives something else. What does it give? Well, it gives a differential equation or set of such of third order with three solutions for the mass. Applied to elementary particle structures, this is three masses like electron, muon, tauon. There we go. Three-generation problem solved. But there is more. There is one important aspect here. As the whole was no postulation, pure math, and is not restricted to any system, it holds for each and every system that can be constructed out of properties, attributes, degrees of freedom, hence dimensions. Each and every system has the potential to exist, fundamentally exist, in 3 generations. Only one is stable, by the way. It could also be the system of the mind. Mind definitively is the most primitive, generation 1, Julius might be 2, and Professor Leuenberger is definitely 3. So this will be topic of paper we are just writing now with all the principles in there. And another application apart from the 4 I've already presented is the question of structured water or T energy or whatever it's being called, because we found out that the fundamental possibility of the new theory or of the generalized theory, being 109 years old after all, is that we can easily explain the occurrence of so-called coherent domains. And what do these things do immediately? They start to radiate somehow. And the radiation is extremely similar to what others call in theoretical physics Hawking radiation. But if you look properly, you have the options for Einstein radiation too. You have all the options. It's all in there. Okay. I started to write this down, wanted to make it a paper, and it ended up to be 410 pages already. Just the coherent domain options. So you see, this is a rich theory, and I sometimes wonder whether Hilbert has already seen it, but avoided the long, hard slog and left it to others. So, applied to mathematical psychology, this just means, what is a human being? Well, you can always characterize, or we tend to characterize human being by properties, right? We allocate attributes to our fellow next and say, oh, this is a nice guy. This one is not so nice. Well, it's properties, 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 properties. And if we analyze ourselves, we often use very, very, very few properties actually to characterize persons. We are not very generous in allocating properties to people. So many things can be explained here. I will not go through this because it's already so late in the day, and I've even stripped Hans from answering your questions here, so I will not over-exaggerate this one. And now we come to the main topic, love. Why do we call this the black hole in the universe of feelings? Well, it's because of this thing here. If you go through all the perceptual properties and attributes, dimensions, which you might need to actually characterize this attractional force of love, you find that it's mainly can come down to just 2, namely one, where you analyze the attractional object, whatever it is, or whoever it is, in a very sober way, meaning the more attractive potential, the more attractive you find it. It's a monotonic chord. I maybe the lie. It's simple. But there's another one, because we human beings have the tendency of mulling things over and over and over again. So we trap certain imaginations, pictures, information we have about the object of desire in certain regions of our brain. And these thoughts are just scattering around there. They are being reflected over and over again. This is like black body radiation. And then you can go into mathematical detail and analyze what happens to these thoughts. Well, they form a pattern, and the pattern is well known. This is just the Planck radiation law. And what does it make it such? Well, the fact that these thoughts have always to be of discrete character. They are packages of information. So they are finite. And the fact that they are finite produces this distribution. always with its maximum at the beginning. You put the two together, the rational one and the irrational one, and have this thing with a Mount log on top. And you might recognize this curve from something else. Something now the sun is going to present.
Yes, I'm going to explain with another example to make it clear. So just my example is going to be, how do we emit confidence? There are two main sources on how we emit confidence. Of course, there are a lot more, but those are just derivatives of those two important ones. And since we don't have that much time, we're not going to go over them now. We can leave them for discussion. So, but these...
Leave the shortcutting to me.
Okay, I will. So these two dominating ways can briefly and dramatically simplified be explained as follows. The A system 1 based, we absorb information and give it away. We show it or mirror it in our confidence level to the outside world. But this depends on how well we have digested this topic or this information. And then we have system B, the system 2 based. We internally reflect upon a certain topic and radiate to the outside world pieces of our inside confidence, independence on our inner state of excitement and or self-assurance. So thereby the outside observer can only detect the sum of these two confidence, system 1 and system 2 based, as a sum. So A plus B. He does not see the true confidence, inner confidence level of the individual. This is hidden within the individual, and you can call it the individual censorship or confidence horizon. Therefore, I will be using the term confidence emittance instead of confidence, since those two can be severely different.
You're sure?
I'm very sure. Okay, so
confident.
I'm very confident, yes. While we can assume that the system, the source A, is of linear dependency, just like in the law, because it is where we absorb the information. It depends on how much information we have absorbed and especially digested. So you might think the confidence emittance increases linearly, but then there's also point B. And this is our more or less innovative source, where new ideas might come from and where we mull over things before we make up our mind. So it is only fair to consider this source as some kind of a cavity in which bits of information are being processed, and especially they are permanently internally exchanged, respectively intrinsically emitted and absorbed. This, however, is nothing else but, just as like my father told me, or told you, it's nothing else but a description of a black body or cavity radiation system. Since the corresponding radiation law is textbook knowledge, we will leave it out of this talk as well. When we now take into account that all the information has to be discrete, so that B results in a quantum system or a quantum-dominated object, automatically producing a Planck-like radiation, we can evaluate the connection between information being absorbed and the confidence emittance for an individual. Here again, we have the same thing as with law. The A is the linear dependency.
Sure.
The A is the linear dependency marked by this green line. Then we have the Planck-like radiation from B with the blue line. And if we put those two together, we get this yellow line. And it is the we immediately recognize the Dunning and Kruger dependency with the Mount Stupid at the top of this, with the red ellipse at the top of this yellow curve.
So we hope severely that you don't consider us being a Mount Stupid. We thought long and hard about this.
Yes. So I think we are over the Mount Stupid. I hope so. But it can be hard to detect if you're really on Mount Stupid. There is even more. It is about temperatures which come into play on how big the difference between A and B truly is. Sure. Yeah, we'll leave that out since we don't have that much time and it is quite a lot. We can talk about it in discussion. And yeah, then I also asked my father, how can I avoid climbing Mount Stupid? There are a lot of factors that come into play when you don't want to climb Mount Stupid. Since I think it was very important to know that. But my father told me the most important thing was a quote from Marcus Tullius Cicero, and it was to never start to stop and never stop to start. I think that's all we can take with us. And one sure thing to know if you're really on Mount Stupid, since it can be really hard, is to talk mainstream nowadays. Yes, this is an illustration of the Mount Stupid. It is where the image of yourself is much, much bigger than the bitter reality. So you think you know a lot, but truly you're just a small fella. And
It's from your system.
yes, this was a picture of my system. No, not of my picture, but from my system. Also, I brought this quote. When you die, you don't know that you're dead, but those around you know it, and it's hard for them. And when it's stupid, it's the same.
Yeah, took some of you a while, right?
Yeah, but in case you want to know more, my father has written a lot of books, and I have published a few videos about it. Here are some references. Those are the books and the references. So yeah, Father, do you have anything to add?
No, you finished it perfect.
Right. Then thank you all for coming, listening, and staying.
Your session ends here.
Thank you very much for your great videos.
Thank you very much. Thank you very much.
And congratulations to your father.
Thanks for the
Too.
chance.
Thank you so
Yes,
much.
thanks for the chance.
Yes, thank you.
Thank you.
I think maybe we have some questions. Huh?
If you want to, but it is late in the day. But no, we of course.
Consider something about, let's say, the EEG from the brain is matching actually trauma resonance. There's no frequency again for the brain. And for the how can they?
Yeah, I mean, the thing is, related to consciousness definitely is one thing we stumbled over many times, namely that obviously the human brain has the ability to create its own quantum world. It's not restricted to the Planck constant. It creates in a kind of, well, Alice Wonderland, its own quantum world, where the degrees of freedom of the classical quantum world are mirrored on bigger scale. This allows for completely different internal radiation patterns where things are possible which seem to be almost unlimited. We struggle more with the boundary conditions defining the limits rather than not being able to find strange stuff. And the thing that what it does not matter what strange radiation patterns you're talking about. There is such a richness of possibilities.
Understood.
Yeah.
This specific radiation, even when for someone with this famous experiment where he was transferring the DNA information
Yes.
into the other one, it was not functioning with all the frequencies. It was functioning only with 7.8 hertz, which is equal to rate of EEG.
Amazingly.
Also equal to first trauma resonances related to the cognitive universe and some radiation and the circumstance of the earth. So only that one.
Well, we just the topography determines upon the possibility of frequencies being selected when forming these coherent domains. and their stability is just guaranteed due to quantum effects on a different level than just atoms. So if you just watch atoms and we have these ER spectra, and then you don't have it all. It does not suffice. You have to go to completely, we call it superstructures in lattice physics.
Thank you so much, Hassan, for your question. Thank you again. I think next session starts in 5 minutes, and we should go to a coffee break.
We do not feel guilty about this.
Okay, thank you.
Thank you. All
Thank you so much.